So we're gonna get started. We're gonna go over some announcements as well as a quick recap while other students are coming in. So, assignments, I made an announcement, I think it was yesterday. We're now gonna extend all assignments by 1 day. So we're gonna release it a day later, but then again, it's also gonna be due a day later. Most likely because the assignments originally were due Monday, but now we want them to be due Tuesday. That way, after Monday's lectures, y'all can come up and ask us for help. And then I know many of y'all probably will have prelims on Tuesday, and so you probably want to spend Monday studying. That way you can use up less slip days. Okay, A1 was due last night. Again, you're given a total of 4 free slip days to use for all assignments. Not 4 for each, but 4 in total. If you had any issues with Xcode or you joined the class a little late, we can probably give you an extension. Just come up to us after lecture and we'll let you know. And so I looked at the assignment survey and there were only, there were like 10 of y'all that submitted something on CMS but didn't fill out the assignment survey. Just a reminder, that is 1 free points. And so please fill that out if you haven't, or if you forgot, just check again and see if you filled it out. Last announcement, we released A2 yesterday, I believe, and it is now due Tuesday, October 24th. Are there any questions? Okay. So just to quickly recap what we've learned last lecture, we discussed classes as well as UIKit, which is the framework that we're going to be using within this course. And so when we want to create, our app with UIKit, then we first need to create views. And so UIKit provides us with classes in which we can create views from. For example, you can have a UI label that represents some kind of label. And so now what these objects have are properties in which you can kind of modify to change the state of that object. So for example, if I have a label and now I want to change its color, I can do .color to change its color. What I'm doing there is that I'm modifying this property of this label object. So if you haven't started A2 yet, it's okay. But if you already did, these steps might become familiar, or this might help you for A2. So the steps to create and configure a view is you first want to start by creating the view. So you create a property, let's say we call it a label, and then we make that, we instantiate it, create a UI label out of it, and then when you create the view, you now want to set it up and configure it. And so inside of the view.load function, we want to create some kind of helper function, and inside of that helper function, it will help us configure this view. And so when we configure the view, we have to change its properties. So for example, a label, again, we can change its color, we can change its text, and there's like a bunch of other properties provided by this UI label class. And then last but not least, after we configure it, we want to add it to a subview of some kind of super view. In our view controller, we usually do view.add_subview. And then once we add the subview, we want to set up constraints. Remember that you want to set auto translates blah 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 equal to false, because that's how we enable programmatic auto layouts. Are there any questions? Okay. So in today's lecture, we're gonna go over, how to develop even more complex applications. In last lecture, we only went over one basic screen with an image view as well as UI label. Today, we're gonna go over how to create multiple screens and how to navigate and communicate in between those screens. So we're gonna start by understanding model view controller. Richie will go over that.
Right, so if you guys remember from last lecture, we only covered how to sort of define views using hard-coded data. So if you remember from last time, we created a UI label as well as a UI image, and we specifically set the text to something within the actual code. A lot of the times in iOS development, it's more complicated than that. Rather than hard coding our data, we sort of want to use data throughout our app that we modify with the views as well as update the views based on this data. So that's where MVC comes in. It stands for Model View Controller. So MVC is a software design pattern, which is a set of rules that sort of governs how we develop our apps, and it's an architecture that we follow when we're writing our code. It's not necessarily something in the code itself, it's more so sort of a structure that we organize our code with. So jumping right in, the first aspect of Model View Controller, or MVC, is the model. So models are essentially objects. They were the data we were talking about earlier. So rather than sort of hard coding the data, we sort of create models that represent our application data. And these models contain information about our application, are often updated based on user interaction or from backend updates, which will come later on. So to give an example specifically of one of our apps that we worked on, in Eatery, we have dining halls, we have dishes, and we have food items. So those are examples of models that occur throughout iOS development, as well as another thing would be the user information when you log in. That is another model that we use throughout our application. So when we define a model, we typically use a struct. So this might be a term you're currently unfamiliar with, as because last time we covered what a class was. So you could sort of think of struct as sort of the sibling of a class. So structs are value types, whereas classes are reference types. So if you remember from last lecture, classes sort of have this concept of inheritance, where you can define a subclass, and that subclass can inherit all sort of the properties and the functions of the superclass. However, a lot of times you don't really need this sort of function. A lot of times you just want to keep it simple, and that's where structs come in. So structs don't exactly have this inheritance, and you really don't need to define a explicit initializer. So when we're creating these model objects, we often want to use structs because they're a lot simpler and they're a lot faster to use. Okay, so moving on to view, that was the model before. Model was the data specifically. So now it's the view. So view is anything that is visible on the screen. So the visible components that are used to build the UI of the app. So this includes what we covered last time with the UI image, UI label, and buttons, and anything that displays on the screen is a view. So in Eatery, everything you see is view. So like the name of the dining halls, the UI labels that contains the dining hall names, the times, everything there is a view. So anything that you see on screen is the view. And last but not least is the controller. So the controller is sort of what mediates the communication between the models and the views. So views and models themselves don't really interfere with each other. They don't really directly communicate. They must go through a controller first. So in UI Kit specifically, a UI view controller is the controller. So for example, tapping on a UI button could trigger a change in sort of the model, and which would also sort of update another view. So if we change the model, we might also update another view later on. So sort of give like a high level understanding of this, you can think of MVC as sort of like watching TV. So you can think of the TV screen as the view. So like this projector monitor right here, well, this would be the view. And you could think of the controller as like the remote controller. You adjust the channels and the content is the actual model. So if you like, you can't really change the channels with the TV itself, right? The channels, anything like that, you don't modify those directly with the TV, and the TV can't modify the model or the channels. You actually use the controller to sort of change that. So the controller is sort of what mediates this communication between the view and the models. So yeah, exactly. Here's an example. It's like when you change channels using the remote, you make changes to the model and you tell the TV to update the view based on those models. Okay, so we're going to move on to navigation.
Yeah, so hopefully Richie's explanation helped y'all understand what MVC is. It's basically an architecture that we're going to be using in this class. And so the reason for having this kind of architecture is because, again, like I mentioned before, our apps can be very complex. In the previous lecture, we only created a single view or a single screen with just labels and then an image. But the thing about that example was that I hard-coded, for example, my name into that label. But then oftentimes you want to have models, that way it can be communicated within other different views within an application. And so one of the main things about the complexity of an app is to be able to navigate between multiple screens. So I'm going to go over navigation. And so I know from last lecture, the idea of a view controller was never, explained. But essentially, in that one class, that view controller class, it has this view to load function that gets called that loads all of your views. And so I guess in this UI view controller, that basically represents one single screen. And so in that one single screen, we initialized properties that are contained in that one screen. So in last lectures, we had one view controller that had my name as well as my image. And those are views inside of this view controller. So what if we want multiple views? What if we want multiple screens? Then we need to use another UI view controller. And so to navigate between view controllers, there are two main ways that we want to do that. The first way is by pushing and popping a view controller. The second way is by presenting and dismissing the view controller. Presenting and dismissing and pushing and popping, the only difference would be the syntax, but the idea of how to kind of push this second view controller from a parent controller is the same thing. So we're only going to go over pushing and popping. So this GIF is kind of a little laggy, but basically if I click on that cell right there, what's happening is that it's telling the app to push another view controller onto this kind of stack. So if I click on notifications and then I click on another cell, it's pushing each view controller onto this kind of stack called the navigation stack. And so what I did there was I tapped back, and what that did was that it popped it from the stack. And so we represent this stack using a UI navigation controller, which is usually created inside the scene delegates in your files. But that's only for Swift 5. If you have an older Swift version, then it won't be in your scene delegate. And so now I'm going to quickly demo how to push and pop another view controller from a parent view controller. So if you go to today's, go to the course textbook, and then go to this section right here. There's a link or an SSH URL that you can copy and then clone it to your computer. I'm going to give y'all like a couple of seconds to do that. Just a reminder, you can just copy that and then Command Space to open up Terminal. Choose where you want to go. So for example, you do, I have a folder called this. And then I already cloned it, which is why if I do ls, it's already there, this lecture 3 navigation. But then you want to do git clone, and then just paste that in, and that should work. Okay, so a quick way to kind of open up Finder from your terminal, if you do open, followed by a dot, and then click enter, it'll basically open up Finder for you, where you can go and open up the folder and then open up the project. Yes. Oh yeah, if you go into the course website, and then click on this section right here, refresh, and then this thing should be here. Make sure you refresh because there's a cache with your browser. Okay, are there any other questions before I move on? Okay, so I already have it pulled up. So I'm going to pull it up here. So if you may notice, on the left-hand side, this thing is called a project navigator. It basically contains all the files inside of this root directory. And so what I did was I created a new folder called controllers. To create a new folder, you just simply right-click and then click on new group. And the nice thing about this is that you want to group kind of all of your files into a folder just to make your code more organized. And so what I did was put in these two view controllers inside of this folder called controller. So now let's take a look at the first view controller. I think it'll help if I actually run that and y'all can see what it looks like. Give it a couple seconds. Okay, I guess I'll quickly, oh, I think it's loading. My computer's being slow today. Alright, this guy does not want to load, so we're just going to move on. Oh, okay, now you want to. Okay, so basically all I have is a UI label that has the word change me in it. And then I have a button called push VC that what I want to do is if I click on this button, it should push the second view controller that I created. And so if you look at this code, in this view controller 1, remember each view controller represents one screen. And so this one screen has a title called view controller 1. So this represents the title right here. And that's the title of this view controller. And then I set a background. And so remember we create helper functions every time we want to initialize a view. And so what I did was create 2 helper functions. One to initialize the button, the other to initialize the label. And so with the button, these are just like a bunch of properties that I used. You're going to need to kind of know how to do this for the A2. And I just basically create the constraints. Same thing like we did in the previous lecture. And then for the text label, the same thing. The only difference is instead of doing text label.text equals to some hard-coded string, what I did is I call this variable text. Now, where is this variable text from? Well, inside of this view controller, I have a property called text, which is a string. And that's basically where it gets its text from. And so I want to create this property here. That way I can kind of pass it into this other view controller. So now to push this other view controller, I want to do that whenever I click on this button. And so if I look at the code for pushing a button, you can see that there's this function called add target. And so when you do self, it just represents this view controller. So the target would be this view controller. And then the action would be the function that you want to call. And so the syntax would be to use a hash.selector and then pass in the function that you want to call. And then what .touchup inside means is whenever you click on it and then you let go, it calls this function. All right, does that kind of make sense a little? Okay, and so now in this push VC function, where do I declare this? Well, if you scroll down, I create this function called push VC. So whenever I click on this button, it's going to call this function. And so there's this annotation that you have to add called @Objective-C, and that you need that in order to use it with this hashtag selector. So every time you're calling a function, or every time you want to use a button and call a function, you need to mark that function with @Objective-C. Okay, so I have a to-do comment here. What it's going to do is that it's going to push this view controller 2. So to do that, you simply want to do, okay, well, first I have to create the second view controller. So to create a view controller, remember, you want to do V for a capital, because it's a class. So if I do view controller 2, I can call that. So now this creates the object for it. And now I want to assign that to some kind of variable. So I can just say let's view controller 2 be equal to a view controller 2. So what I'm doing here is just basically creating this object and assigning it to this constant right here. So now that I've created that object, I now want to push this view controller into this navigation stack. Now where is this navigation stack? Well, as I mentioned before, inside of the scene delegate file, I already created this code. In your assignment, this code will be created for you. So basically what I did was this navigation controller, remember that represents the navigation stack. I had this root view controller. So the root view controller of this navigation controller will be the first view controller. So whenever I launch the app, the first view controller will be this view controller. Does that make sense? Okay. So now I want to add onto this navigation controller. So if I go back to this code, to do that, you would do navigation controller and then do dot push view controller. Click enter. And now I want to pass in the view controller that I want to push. I already instantiated that object here. So now I'm going to do view controller 2. And so now this animated argument that it takes in, it's a Boolean, so it can be true or false. So what animated does is, remember how whenever I click on that settings cell, it push a new view controller with an animation? If I set it to false, it would just instantly push that without having that sliding animation. So if you want your absolute clean, make this equal to true. Okay, so now let me do Command R to run the code and see if this works now. So if I click on this button, it now pushes this view controller onto the navigation stack. Okay, are there any questions? Yes.
Can you explain sorry, I might have not taught this, but like the optional behind navigation controller when you push to these?
Yeah, so basically, this navigation controller is a property inside of this main view controller. So because this is a subclass of UI view controller, it automatically inherits this property called navigation controller. But now, that navigation controller might not even be there, right? Whenever inside the scene delegate file, I might not even use navigation controller. So what it does is that it only pushes view controller if this value is not nil. So this is called optional chaining. This question mark means that, hey, if this navigation controller is not nil, then call this function right here. Does that make sense?
You don't have to explicitly set like navigation controller equals. It just automatically figures it out even though you named it an arbitrary variable.
Exactly. So whenever I push this or I created this navigation controller and pass in that root view controller, it automatically knows that that navigation controller is this navigation controller. Does that make sense? Okay. Did you have a question back there? No? All right. So I'm going to go back to the lecture slides. And now Richie's going to talk about delegation, which is a way to communicate from that child view controller back to the parent view controller.
So I guess before we jump into delegation, just a bit of a disclaimer. This is sort of one of the topics that a lot of the students in previous semesters struggled with. So if you have any questions, feel free to raise your hand, and especially ask a lot of questions on EdSTEM if you have any. So Vin covered earlier that we have multiple navigation controllers or view controllers. So we have the child view controller, which is the view that you push, and we have the parent view controller, which is the view controller you push from. So oftentimes we sort of have multiple view controllers, and we can push and pop them. But we also want to communicate with them. We want to send information back and forth between these view controllers. And this is a lot more intuitive when it comes from the parent to the child, because you're calling from the child view controller from the parent view controller. So there's sort of this flow of information where you can directly pass information to the child. However, when you're passing information from the child to the parent view controller, things get a little more complicated, because you don't really directly have access to the parent controller while you are in the child controller. And that's where sort of delegation kicks in. So delegation essentially allows, most of the time, for a child view controller to communicate with its parent. So we typically use protocols to do this, and we'll go into that a little bit later. But essentially, the terminology here is going to be a little confusing because all of these words sound the same, essentially. So we have the delegator, which is the VC that is delegating the task. It wants the other VC to perform a task. This is often the child VC telling the parent to do something. And the delegate is the VC that's being asked to do something. So this is oftentimes the parent view controller, and this is the delegate that will conform to the protocol, which is sort of the language that allows us to communicate between the delegate and the delegator. So a lot of these terms don't really make sense when you first think about them. Delegate, delegator, they sound very similar, protocol. So if you sort of think of this as like a sort of real life scenario, you could think of this as a bar, right? So at a bar, you have a customer, a bartender, and you have a menu with all the drinks. So you can think of the delegator as the customer. The customer wants to order a drink or tell the bartender to do something. And the delegate, in this case, would be the bartender. The bartender is being told to do a task. And sort of what mediates the communication between these two is the menu or the protocol. So you can think of the protocol as the menu, the delegator as the customer, and the delegate as the bartender. So that, if you think of it sort of in that way, rather than using delegate and delegator, it might be a little more intuitive when you're thinking about how this works in our MVC model. So to go into a little bit more about protocols, so these are a set of properties and methods that a class must implement So you can think of it, if you've taken 2110, you can think of it as like an interface in Java. Essentially, if a class implements a protocol, that class has to implement all functions and properties that are specified in that protocol. So typically when we want to sort of implement a protocol, we extend a class using an extension. And this extension word is a keyword to our classes to create, and essentially this makes our code more neat. You can directly sort of implement it using sort of treating it as a subclass, but it's often more neat to use it as an extension. So there's an example in the next slide here. So sort of to break this down a little, this might seem a little intimidating at first sight. So we have our protocol, which is sort of the menu that we want to use as sort of the branch between the delegate and the delegator. We have the parent view controller, and this is the delegate. This is the view controller that we're telling to perform a task. So this is the view controller that implements the protocol. So you can see here, we sort of extend with this extension keyword, parent view controller, to be the update text delegate, which is the protocol. So let me repeat that just in case you didn't get that. So the parent view controller is the delegate that implements the protocol that sort of has the language of communication that allows the delegator to do a task. So the child view controller here, you would think of that as the customer telling the parent view controller, which is the bartender, to sort of create a drink based on the menu, which is the protocol. So you see here in the child view controller, we sort of have this weak reference to the delegate. So the delegate allows us to communicate with the parent view controller. And while you would set the delegate here to the parent view controller because it implements that update text delegate. So here it gives us access to the parent view controller through the child. So here, let's say we wanted to sort of tell the parent view controller to update text in this case. We'd do update text delegate dot update text, and that would essentially tell our parent view controller to perform whatever functionality is written in update text. So again, to reiterate, you could think of the protocol here as the menu that sort of allows communication between the bartender and the customer. You could think of the parent view controller as the bartender that is accepting a task and can only understand sort of what is on the menu. And the child view controller is the customer that orders a drink based on the menu and provides this task to the bartender, which is the parent view controller. So again, this might be very confusing, but Vin is sort of going to go into like a bit of a demo so it becomes more concrete.
Okay, y'all, so I'm going to demo delegation. Y'all are probably like, oh, what the hell is Richie talking about? But
I guess like
it will make more...
before we move on, does anyone have any like questions? Yes.
Was that second thing a class that was using the protocol you got?
Right, so parent view controller is a subclass of view controller. So like Vin demoed before, you sort of have the parent view controller that is a subclass of view controller. And then same thing with child here. Child is also a subclass of view controller. So you just sort of think it's sort of the same structure as this, except parent view controller is also extending with the protocol. Yes.
Wait, where do you write like the first two blocks? Is like protocol global, or is it within one of the classes? And is extension like within the parent view controller class definition?
So you can essentially write protocol in any file, and you have access to that between all view controllers. So it's essentially public within all of your files. So any view controller on any file within your project will be able to access that protocol and implement it.
And then what about extension? Is that like the signature you're talking about?
So yeah, extension is sort of the key word that you use to extend the class using the protocol. It's sort of like the implements keyword in Java, if you're referring to that. So this class implements the protocol, meaning that whatever's in the protocol, this class has to implement and include. So if you see that there's an update text, there's sort of like a stub for a function there. But in the actual parent view controller, since we're extending it, we actually have to provide the implementation for that class.
How does parent view controller relate to child view controller?
So parent view controller, if you remember from the previous demo, parent view controller is sort of the view controller that you push from, right? You remember we clicked on the button? The button that pushes the view controller or brings that screen on, that is the parent, and whatever is being pushed onto the screen is the child. So the child sits on top of the parent.
Okay. All right, it will make more sense whenever I demo. So remember from lecture 1 or lecture 2, you can check out the branch. If you do, you might have to do git stash first, and then run. So once you do git stash, it's not going to work here because I'm not in the git area. But if you do git stash, and then do git check out 1 dash, I believe it was navigation, you'll be up to date about what's where we're at right now. Okay, so it's not going to work for me because I'm not in that. I'm just going to create from where I started. So right now our app, if I click on this push VC, it pushes the second view controller onto this navigation stack. And now what I want to do is inside of this text field, I want to be able to add some text. And when I hit pop VC, it should dismiss this view controller as well as update this text right here. So in other words, I'm communicating from this child view controller to the parent. Okay. So now first, you want to be able to pass in information from the parent to the child. So what I'm going to do is this placeholder text right here, I'm going to set that equal to this value change me. Okay. So when I did that, well, how do I do that? Well, whenever I create this child view controller, so the child, again, is view controller 2, and the parent is view controller 1. Whenever I created that object, that's how I want to pass in information to it. So one way to pass in information would be to do it through the initializer. So whenever I instantiate this object, I can then pass in this variable, this text, into the second view controller. So this view controller 2 needs to have some init function. So if I do init, you want to use, let's see. Yeah, you don't want to use any of the built-in ones. You want to create your own. So you do init. So the thing that I want to pass in would be the text. So I can say init text. Its type will be a string. So if I run that, or if I save that, you can see that there's like this button that you need to create. It's required every time you create an initializer inside of a view controller. So now what I'm going to do here is be able to set this text right here, this text to be equal to the text that I pass in. So what I can do is create some kind of property that stores that data. So I like using mark comments to kind of make your code more neat. So these are like data properties. And so I can create a private var. I'm going to call it, I guess, text. Its type is going to be string. And for now, let me just initialize it to an empty string. So now in this initializer, it's going to take in some argument text and then assign it to this variable text. So can anyone tell me how do I assign this property text equals to this value? Yes. Exactly. You want to do self because it represents this object. So self.text equals to text. And then again, because this is a subclass of UI view controller, you want to call it its super initializer. So you want to do super.init. And the one that you want to use is libname and bundle. And then these are optional, so you want to set that equal to nil. So now when I go back to view controller 1, I want to pass that in to this view controller. So you can let it autofill. Now what text do I want to pass in? Well, I had a property called text here, so let me just pass that in. So you can pass in this other text. And now if I go back to view controller 2, this placeholder, instead of calling it placeholder, I can now be more flexible and use the property that I pass in. So this is what I mean by making your apps more complex. I'm not just hard coding placeholder now, I'm using in information from another view controller. Yes?
Why don't you use self.text for the view controller 2 instantiation?
So where at?
In view controller 1,
Uh-huh.
when you create an instance of view controller 2, why don't you do self.text? Because I thought that text.
Oh. Yeah, that's actually a really, really good question. You actually can do that. It doesn't make a difference, but normally we don't want to use self when we don't have to. But here, you had to use self. Actually, I don't think you need to use self here at all. Actually, yeah, you do need to use self because this text right here, it thinks that it's a parameter text. So you want to make it clear that this is self. If I call this like my text, for example, then I can use text because it's not referring to this text. Does that make sense? Okay, that's a really good question. Okay, so now if I run this again, then hopefully the second view controller should have the word, this word, what was it?
Change me.
Change me. So I push it and now it has changed me. So now what I want to do now is to be able to change this value. If I hit pop VC, it's going to pop this view controller and then change this parent view controller. And now in order to do that, we have to use delegation. So the first step to delegation, number one, is to create a protocol. And as Richie mentioned before, you can create that anywhere because it can be accessed by any one of your classes. So I can call it right here. Let me create some protocol. Now, it has to be lowercase p. And then you want to call it something that's, I guess, easy to remember. So update text delegate, because it's updating a text. Now you want to conform it to any object. We will go over this in like a very far lecture for now, but for now, just copy this. And now remember, a protocol is basically a menu that is shared among these two view controllers. And so I can create some kind of function that allows me to pass information from the delegator to the delegate. So if I create a func, I can call it update text. And now this delegator, this child view controller, needs to pass in information to the parent view controller. And I can pass it through this function right here. So inside of this function, I can create a variable called, let's say call it text, or I'm gonna call it new text, make it more clear. New text. Its type will be a string. And now this protocol is basically an interface. You only declare the function header. You don't create the implementation of that. Okay, so now that I've created this protocol, the next step is to tell this view controller 2 who the delegate is. Who do you want to tell it to update text? So that means this view controller 2 needs to be able to store this reference to the parent. So I'm going to create a property and I'm going to mark it as weak. So make it private. I'm going to call it weak. We'll explain this in a future lecture, but for now make it weak. It's going to be a variable and I can just call it delegate. And now its type would be update text delegate. Now notice how I created that protocol inside of view controller 1 inside of this file. Remember, you can still access it. Now you got to make this an optional. Okay. So now this child view controller has this property called delegate. Now the parent view controller needs to tell the child who the delegate is. So similar to how we told the child view controller what text to do, what text to put, we're going to do the same thing with a delegate variable. So I'm going to say delegate will be equal to update text delegate, and then set self.delegate will be equal to delegate. Okay, so now if I go back to view controller 1, whenever I initialize this view controller, remember you're telling it who the delegate is. So can anyone guess who the delegate is? What do I put in here? Self, exactly, because this parent view controller is the delegate. Okay, so now there's an issue though. Xcode is saying that you can't tell this view controller 2 that you are the delegate. The issue is because this view controller needs to be able to conform to that protocol. So this protocol that I declared right here, I have to conform to it in order to pass myself as the delegate. So remember, I can put update text delegate here, but it's common to create an extension which basically is expanding this view controller. So right here, I'm going to create an extension, and it's going to have the same name as your class, so view controller 1. And now I want to conform it to the protocol that I created before, which is update text delegate. And remember, when you conform to this protocol, it means that you need to implement the functions that are defined in this protocol. So the function that was defined in this protocol was called update text. So now I need to create the implementation for update text. So So if you do func update text, it'll autofill for me. And so basically what's happening is that in this second view controller, I have a reference to the delegate. Inside of here, I'm going to tell this delegate to update its text. I'm going to do that by calling the function. So if you go to, so this button that I created, remember this target would be to call pop VC. And inside of here, what I want to do is pop the view controller. So similar to pushing a view controller, you want to do navigation controller dot pop view controller. And let's make that animated. So whenever I tap that pop button, it'll pop this view controller. Now, in addition to popping, I want to also tell the delegate to update its text. So the reference that I have is that delegate property because I passed in self as the delegate, and now I have access to that. I know I have a reference to it. And now because it conforms to this protocol, I can now access its function called update text. So tell the delegate, so I'm the delegate right now, I'm telling the delegate, hey, there's this function that you've implemented called update text. I'm going to pass into you this new text. And so the text I'm going to use will be the text inside the text field right now. So I have a property called text field. So you do text field dot text. It will basically give you the text that is currently in this text field. Now because text field dot text is an optional, I'm going to use no coalescing to give it, let's say, an empty string. So now I told the delegate, hey, update your text. So now the delegate needs to know what to do with this information that I passed into it. So if you go to view controller 1, that's how you, inside of this function right here, that's how you kind of, this is where you want to do whatever the delegator is telling you to do. So it's telling me to update my text. So what I'm going to do now is I want to change this label's text. So I have a text label right here, a property called text label. So can someone tell me how do I update this text label's text? Yes. Close. I'll actually do that. So I'll do self.text equals new text. Now remember, you don't really need self because this is called new text. So I can just use text here. Well, that's good because we also want to change this property right here. That way, everywhere I use text, it'll be changed. But not only just that, I also want to change the label because this right here is only being called whenever you initialize the view. So that this text title label, this text label won't actually change its text until I actually tell it to. So I can do text label dot text and now assign that equal to new text now. Okay, so now if I run the code, okay, so now I hit push VC, change this to like hello. Now if I click pop, it now updates the parent with that new text. So that right there is delegation. In assignment 2, we're going to be the same thing, but we're going to be doing an edit profile page. So you create this view controller 1, which is the parent view controller will be a profile, and then the child view controller will be an edit profile, where you will have these text fields that you can change, and then when you hit save, it'll update back the parents. Yes?
So I get that like you define this function in the parent class and the child class, but is view control 2 a child of view control 1?
Yeah, it's not really it's not a subclass of view controller 1, so I guess that's a little like unclear. What I mean by child and parent is the parent is the one that is creating this second view controller. So inside of this code, I created this view controller 2 object. So technically it is the parent, but parent-child does not really mean subclass and superclass. And so I create this view controller 2, and that's basically the child of this parent controller. Does that kind of make sense a little?
Yeah, but like so you define the function in the parent class. When is it actually like called and pass something into the event updates?
Yeah. So I basically told this child view controller who the delegate is, which is myself. And so I did that whenever I pop the view controller. So when I tap on this button, it calls this function that pops the view controller, and then it calls the delegate, and I pass in self as a reference. So it calls a delegate and tells it to update its text. So whoever conforms to this protocol will have this update text function. And so I basically, whenever I do update text, it will basically call this person's update text function. Does that make sense?
So delegate is an object of the view controller.
Yeah, it's a reference to the parent view controller. So that's how I can call its functions, because it has a reference to it. Yes.
So like looking at view controller one, the protocol in that file, that's like the equivalent of like a Java interface.
Exactly.
And then like the view controller one, like does it extends UI view controller like in terms of like Java and stuff?
So this right here?
Yeah. Is that
Yeah,
like,
yeah.
Extends it?
Yeah, so
If
this.
you wanna implement stuff, you have to like do it separately and
Yeah, so basically this annotation is kind of stupid because this extends it, so it's a subclass of UI view controller. But if you want to conform to a protocol, you would have to do this. It's the same syntax. So instead of doing an extension, I could have literally just put it in here, update text delegate in here.
oh I see.
But then I can create that function inside of here.
So is that also like an extension, or is that like an implementation? Like it's just unclear in Swift, Twitch, or Switch?
So when you're using the colon notation in any class, it could either mean it's a subclass inheritance of that superclass, or it's an implementation of a protocol. There's no real distinction between them. That's the confusing part about Swift. But sort of when you have that sort of colon notation and the comma separated classes, you can either have an implementation of a protocol or a superclass inheritance.
Gotcha, that makes sense. Thank you.
So we're gonna quickly do a Kahoot for attendance. So pull out your phones. Oh shit. Oh.
Nah, no one saw anything. No one saw anything.
Yeah. Want to do your prize? Do you want to do your prize?
Yeah.
Should be quick. I don't care.
I feel like you can't make food.
Yeah, get a speaker or something. Speaker. I don't care. We're using active budget.
That's true.
It's the same thing.
Do you have to review the answers?
Me? No one noticed. No one noticed. It's very quick.
No, I just like.
We're gonna give another 15 seconds. We're a little bit over time, but yeah.
You all good?
Okay. Yeah. First question. Which of the following is not an anchor in NS layouts? Ooh, okay. So we noticed that in the lecture slides, there's this thing called left anchor instead of leading anchor. So that's the reason why I kind of put this up here. So we want you to use leading anchor. So left anchor and leading anchor are basically the same thing, but it's actually just flipped depending on the language. So, for example, in Japanese, the left would be on the right side because read from right to left. But in this class, we want to make sure you use leading anchor instead of left anchor. And then instead of right, we want to use trailing anchor. And then middle anchor does not exist. All right.
Okay, next question. So you should set translate auto-sizing mask into constraints to false when using programmatic auto layout.
Wait, ignore the phone number. Wait, hey, guys, don't call that phone number. Wait. Wait, I think it's Joseph's number.
Hey, why did you take a picture?
Hey, y'all, don't call that phone number. Okay, you can explain.
Okay, so before we set any constraints, you need to make sure you convert from storyboard layout to programmatic Swift layout. So that's why we need to set translate auto resizing mask into constraints to false before setting in constraints. Alright.
The initializer of a subclass must call the superclass's initializer. So super.init. Yeah, so the answer is true. A subclass must call the initializer of the parent's class. So let's look at the leaderboard. Oh yeah, we also, honestly, we might just give y'all a prize if you're, if at the end of the semester, if you have the most points, we'll give you something, I don't know, whatever y'all want.
We'll figure out a prize.
Yeah.
Something worth your while. So I
ML
would get these right.
ML2735, good job. So before y'all leave, there are some quick announcements I have to make. Wait. Okay, so mentorship form and the ad deadline is tonight at 11:59. Please fill that out. A2, remember, it has been released and it's due next Tuesday. Partners are matched already. We will only make accommodation if you have a partner in mind. If you're still looking for a partner, we can only do that for A3 and A4. Make sure you shoot me an email if you want to partner up with someone. And then if you want to partner for A3 and A4, just make sure you fill out the same form that I put on a discussion. All right, y'all are free to leave. Make sure y'all don't text that number or do anything weird.